Welcome to the Surgibots Podcast, powered by Cruxx.
We think now is the time to make sure we can open up access because the technology and the environment is ready.
We're not building a robot. We're building everything else that enables a robot to operate at distance.
How do we create a scalable model for enabling remote surgery and procedures? It needs to be the way a health system, a surgeon does business. It can't be a one-off and be safe and sustainable.
These robotic systems are not only being built for surgery, but they're also being built for interventional procedures, they're being built for diagnostic procedures, and all of them can benefit from a remote capability.
We believe the way we're designing this network is actually a very cost-effective way of doing it, in addition to being the highest reliability and the safest approach.
Before we deep dive into this episode, I wanted to take 30 seconds to introduce you to the sponsors of this season of the podcast, TTP. TTP is a technical consultancy that has a 35-year track record helping companies transform innovative ideas into market-ready products. Their 300-strong team of scientists, engineers, and designers all under one roof can take care of your surgical robotics or imaging technology from a napkin sketch all the way through to early stage commercialization. I was lucky enough to get the invite out to their Cambridge facility. They gave me eyes on a number of the projects they're working on, and not only is the facility state of the art, but the main competitive advantage I see with these guys is their people. A group of incredibly smart, focused and friendly guys who do not shy away from a lofty engineering challenge. If you want to learn more about some of the work they've done or to talk more about a project you have in mind, shoot me a message on LinkedIn or visit their website, ttp.com, to get in touch with one of the team. Hello, Cynthia and Yulun, and welcome to the Surgibots Podcast.
Thank you. Great to be here.
Nice to meet you.
Awesome. So thank you very much for coming on here. So to kick this off, I want to get a bit of background on the both of you. So Yulun, if we start with you, tell me a bit about where you've come from and where you are now.
Yes, thanks, Henry. So I'm an engineer by training. I studied robotics in school. I started my first company, Computer Motion, in 1990. That ended up going public and then merging with Intuitive Surgical in 2003. Then I started a company called InTouch Health in 2003, which did surgical telemedicine, and that went through 2020. Then it was acquired by Teladoc Health. And then in 2021, I connected with Cynthia and started working on Sovato, which we incorporated in 2022. And that brings us up to today.
Awesome. So take me back to the early Computer Motion days. What was your role within Computer Motion and then moving through when it was acquired / merged with Intuitive?
So I was the CEO and founder, and so I was, worked on developing our first product was called ESOP, and ESOP was a single arm robot, and it held the laparoscope for the minimally invasive surgeon. Under voice control, it was moved, and it was the first FDA cleared surgical robot. And then, that went on and continued. We developed a system called Zeus, and Zeus was then a 3-armed robot. The surgeon sat at a console, much like you see in the robotic systems today. And that was used for lots of different types of mainly laparoscopic surgery, but it was also thoracoscopic surgery in the chest area. The one thing we also did with Zeus, which has gotten quite a bit of attention over the years, is we used Zeus to enable Professor Jacques Moresco in 2001 to do what's today called the Lindbergh operation. He sat in New York City and he operated on a patient in Strasbourg, France. And so that was done on September 7th, 2001. And then InTouch Computer Motion was merged with Intuitive, but that procedure was the one which got me introduced to the concept of telemedicine, and that's why I started InTouch Health.
Okay, awesome. And so take me through InTouch Health then. So what did the company do in terms of telepresence?
So InTouch started in 2003. If you can remember back then, it was actually, even the internet was kind of new, and doing healthcare over the internet was kind of a new idea. the world definitely was not ready for a telesurgery at the time, but we thought that the world was ready for enabling a clinician to consult on a patient at distance using the internet, the backbone, and then building a lot of technology on top of the internet to enable a very comprehensive interaction between the clinician and the patient. And so AimTouch did that, and then it found its use case, the primary use case, which drove the early success in the business, to be telestroke. So a person has a stroke, they come into emergency department, there is not a stroke neurologist there, and we would beam that stroke neurologist in using telemedicine to do rapid assessment and treatment of that patient. And so that turned out to be a great use case because the clinical benefit and the economic benefit to the health system aligned, and we were able to grow that company really based on that initial use case. Obviously today, telemedicine is very broad-based in terms of all of its different use cases.
Absolutely. Well, thanks for going a bit into the background there. And Cynthia, let's walk into your background and talk me through it. And how did you end up teaming up with Yulun?
Yeah, great question. So, my career has really been at the intersection of technology and disruptive trends. So started out post-business school working for a very early EMR company that was trying to take advantage of wireless communication. This was sort of pre-internet and pre the year of the EMR at HIMSS in 2008. Then I moved on to a company that was really focused on the consumerism trends. And this was also in the late 90s, where we thought that the consumer, the patient, should be the source of truth for their personal health information. And that was, during the era of, the e-everything, I.something. So after the financial market kind of fell out, I went to Premier, where I spent many years leading corporate development and working on things that could help health systems really transform, particularly bringing quality to the forefront and value-based care, and worked on, exporting the value-based purchasing program that CMS ran globally. I ended up going to a health system in Southern California, where my role was to really drive growth, bring innovation in, ended up, consolidating our telemedicine efforts. Yulun was actually on the board of that health system here in Southern California, which is how we met. And then I spent some time working with a professional services firm who was really trying to help health systems figure out which digital solutions would really move the needle for their important imperatives. So when Yulun called me and said, do you think now is the time for telesurgery? It was, in the middle of COVID, the health systems that I was working with were all trying to bring surgery back. We're trying to find growth strategies. We're trying to stabilize commercial share. So I said, yeah, I think, anything that can open up access in markets that health systems are finding hard to serve is going to be a winner. And so we spent a lot of time looking at the trends and the macroeconomic forces. And so we decided to join up and create Sovato.
Awesome. And we're going to dive into Sovato in a bit, but can you start off with a definition of what is telesurgery?
Yeah, I can start, and then Yulun can chime in. So, as we think about telesurgery, we've been using the phrase remote surgery and procedures because we are really focused on enabling the access to surgeons when they're not physically located with the patient, so that they are actually remote. There is a definition of telesurgery because surgical robots have been connected by cords for many, many years. So we've been doing telesurgery since Yulun invented ESOP and Zeus, but we're really focused on remote surgery, where we can really enable scarce resources to be connected to patients at distance. Yulun, what would you add?
No, I think that was well said. I think as Cynthia first said in response to your question, she said remote surgery and procedures. And because as we've gotten into the market with Sovato and talked to a number of different companies, what we're learning is that these systems, these robotic systems, are not only being built for surgery, but they're also being built for interventional procedures, they're being built for diagnostic procedures, and all of them can benefit from a remote capability. And so the phrase that we're using now with Sovato is we're enabling remote surgery and procedures.
Okay, so what's that procedure side then? So it's outside of surgery, just the interventional side? Like, talk me through that.
I think the two categories, broader categories outside of surgery, are interventional procedures, which could be endoluminal, they could be endovascular, and then there's the diagnostic ones, which are typically either endoluminal or endovascular as well, but they're not therapeutic. And so those are the other categories.
Okay. So Cynthia, why is telesurgery needed now, and why did you guys decide that now was the right time?
Well, I think there's no lack of understanding about the workforce pressures in healthcare. And the trends for physician training over the last many years have been subspecialization, which has led to great advances in our ability to treat disease and injury. But it has also created a shortage. The general surgeon and the general practitioner, is a waning resource, very valuable, but they're just fewer and far between. So and there are, it's projected that over 30,000 physician and surgeon shortage will be at hand by 2030. So a shortage of over 30,000 surgeons in the United States. So how do we make sure that we get the care that patients need when they need it? Well, it seemed that because of the advances in the telecom infrastructure, the proliferations of the types of surgical robots, as Yulun was mentioning, the acceptance of telemedicine as a format for receiving care, as well as the regulatory and payment landscape, like the macro forces are lined up for now to be the time. The why is really present. Patients are not getting the care they need from the highest quality surgeons on a consistent basis. If you don't live in LA or New York or San Francisco or one of the big major metropolitans, you're either driving or your surgeon is driving to you, or you're actually going without, or going with someone who may not be as skilled to bring you the highest quality care. That's just the reality. So we think now is the time to make sure we can open up access because the technology and the environment is ready.
Okay. And so, Yulun, is this about creating kind of an omnipresent surgeon who will go across the world and operate on people, or are there different use cases for the telesurgery?
Well, so Cynthia, do you want to take that?
Sure. So the answer is yes and no. So the goal is to make the right surgeon available to the patient that requires that skill set, and being able to bring that using robotic surgery, trained care teams, and the right telecom infrastructure. So there are a variety of models that will enable this. One is, a trained surgeon working with a care team, 500 miles, 1,000 miles. The one restriction will be, can we get the right infrastructure to those places? But we're pretty confident that most places, particularly in the United States, we will be able to get those resources. Could be a co-surgery model where a general surgeon in a community is taking care of a patient and has a highly specialized, say, colorectal surgeon participate in that surgery remotely to take care of the pieces and parts of that surgery that they're specially trained to deliver. That's similar with diagnostics. Imagine a model where you can go to your primary care doctor's office for your bladder cancer surveillance, which you're going 3 to 5 times a year for that surveillance. Instead of having to wait months to get a urology appointment, you could go and have that in the comfort of your hometown primary care doctor's office. So those are the types of models we're seeing. And it's really, it's not necessarily about omnipresence, but about matching the right patient to the right skill set.
Okay. And so how do you guys enable telesurgery? So what does Sovato do, and how do you guys enable it?
So maybe I'll start, and Cynthia can certainly add to what I'm saying. I think we're not building a robot. We're building everything else that enables a robot to operate at distance. So what does everything else mean? One piece of it is surgical robots or even procedural robots have two sides. One is where the surgeon sits, and the other side is the manipulation tools which operate on the patient. And those systems are all connected by a cord. And so one significant piece of technology we're building is all the infrastructure to allow that 20-foot cord to be replaced by 1,000 miles of distance or 2,000 miles of distance. So that's one piece. The second piece is, now that you have a patient and a surgeon in different locations, and that patient has a whole longitudinal journey from when they first meet with clinicians to see if they even need surgery, and the patient selection process, the workup which leads to surgery, the actual surgical event, and the whole follow through. Basically, they want the care strategy of the surgeon in that person's institution. We're building a software system which enables the orchestration and coordination of the two locations, one being the patient's location, one being the surgeon location. And then the third piece we're building and developing are the business models and the regulatory processes and the policy processes to enable everybody to do it safely and to make money in the process.
Okay. So what are some of those hurdles that you guys are going to have to come across? So you said that policy and regulation is going to be a big piece with what you guys are doing. So what have you got to come over? What are the challenges, and I guess what are the pushbacks?
So from a regulation perspective, surgical robots are regulated medical devices. And as we think about extending their use into new locations with different workflows, we are collaborating with the FDA at this time to understand how, this remote procedures and remote surgeries will be regulated. So that's an ongoing dialogue. There are policies that I think telemedicine has started to make more clear, such as we always get the question, state licensing. Yes, you do have to be licensed to provide care in the state that the patient's in. So if we're doing cross-state surgeries, you will have to be licensed in the state where the patient is. Similar questions about credentialing. You will have to be licensed at the medical facility and credentialed at the medical facility that the patient has. But a lot of the processes to streamline that licensing and credentialing have, Yulun's, been knocking those barriers down since 2003, and there's been a lot of movement, particularly in the United States, to streamline those processes and make that easier. It's a known approach. I think we'll be pioneering on reimbursement. This actually opens up some new creative reimbursement models that are probably more cost effective for caring for patients. So we're excited to explore reimbursement models. And then there's questions about medical liability, which will also need to be answered as we move through this. And maybe Yulun can talk about some of the telecommunications approaches that we're taking that can manage some of the technical issues, which are important, but we think solvable.
Yeah, so, there's that 20-foot cord which we're replacing. The 20-foot cord is a very deterministic piece of technology in terms of you shove a bit in one side, it comes out the other side very deterministically. So now if you're going over distance and you're going over, thousands of miles, and we are using the telecommunication infrastructure, how do you do that where it's very deterministic? And we have a whole strategy of building a private curated network based on fiber optic communications. And so, for example, we're not using any wireless, we're not using any 5G type of technology in it because we believe it's non-deterministic. And we're using data centers in order to create the feeders into this deterministic, curated, private fiber optic network, which will initially span the country and it will eventually span the world. And so that's kind of how we're going about it. And then we need to be building software systems which know how to manage and monitor and use fleets of software. One of the things, there's been quite a few companies which are now starting to demonstrate telesurgery examples, primarily out of China, and they're doing great work, but they're doing one-to-one connections, which is the right starting point. But imagine when you have hundreds and thousands of robots which are being used remotely. Now you've got to deal with fleets of robots, fleets of heterogeneous robots of different types. And they might have, even the same type might even have different versions of software. And so how do you manage all of that effectively? And so we're building a whole kind of platform infrastructure to take care of that as well.
So the core of your question, Henry, is how do we create a scalable model for enabling remote surgery and procedures? It needs to be the way a health system, a surgeon does business. It can't be a one-off and be safe and sustainable. So from the very beginning, we thought about what does it take to make it safe, scalable, and sustainable. And by sustainable, we mean financially viable. And as we thought about what are the things that need to be in place, there are the threshold things like the connectivity has to be reliable and safe, but supporting the surgeon and the care team so that the entire surgical journey can be implemented as if the surgeon was driving that locally was one of the challenges we needed to solve. We learned early on, and from my time at a health system where we were building clinical programs, that while the surgical event is a very important input to the outcome of the full surgery, from patient selection all the way to post-discharge care, everything that happens to that patient along the journey is an input to what the outcome will ultimately be. So I think you will find that the need to focus on the entire surgical journey, inclusive of the surgical event itself, is an important step to making this scalable so that it can be done routinely, safely, which at the end of the day is what brings confidence to that surgeon to step up to the console, perform that surgery, step away from the console, and know that the local care team can take that patient through an acceptable outcome.
Sure. And I think you guys are booking the trend. Is like a lot of people are talking about 5G, and a lot of the remote surgeries that we've seen so far have been done over 5G, and a lot of people are laying their eggs in that basket. But fiber is where you guys are going. It makes a lot of sense because there's a lot of hospital infrastructure that's already fiber. But yeah, talk to me. So 5G, what are the challenges with 5G, and why is that going to be difficult for some of those companies to manage that fleet, Yulun? That's maybe the technical side of it. And yeah, tell me about what fiber actually allows you guys to do.
So first of all, 5G is a protocol which actually uses wireless, right? Because like my phone here has a 5G connection, and as we all know, because we all use these cell phones, we go around the corner and all of a sudden the connection's not very good. And so the latency, the jitter, the connectivity is suspect in terms of can 5G be reliable enough in order to do telesurgery. The other thing about 5G is based on the protocol is if, say, I have a very good connection, but then Cynthia starts downloading a video off the same tower, and then you start downloading another video off the same tower. We're sharing the bandwidth, and pretty soon it will just drop to an unacceptable range. With fiber optics, first of all, fiber optics is the bandwidth capability of fiber optics is orders of magnitude more than 5G in the first place. And then by securing specific dedicated bandwidth, we know that no one else is going to impede on it. And then if we're connecting, for example, using fiber from the West Coast to the East Coast, we know exactly the direction, the pathway all of those bits take, as opposed to if you're using kind of standard IP routing over the internet. We actually don't know how it's going between the West Coast and the East Coast. The routers determine that along the way. And so the fiber, it's faster, it's more deterministic, it can have more bandwidth, it can have lower latency. So all of these things are critical for telesurgery. And then last but not least, we did a study, and we know at least 95% of the hospitals in this country, at least, have fiber going into it. It could be closer to 100. We just couldn't figure out that last 5%. But so it's very, very pervasive to be able to use the strategy we're using.
And just to put an exclamation point on what Yulun said, it's become very cost effective. The cost of accessing dedicated fiber today is order of magnitude lower than it was previously. So we did a lot of studying because we know our customers are health systems, and everybody knows that adding cost to the system is unacceptable. So we believe the way we're designing this network is actually a very cost-effective way of doing it, in addition to being the highest reliability and the safest approach.
Yeah, so you've touched on a really interesting point there, is robots are already really expensive. How can you enable telesurgery with your platform to be cost-effective to the health system?
Well, as we went out and talked to many surgeons, hospital administrators, what's clear is there are probably at least three very clear economic value propositions. One is creating access to new markets, or said another way, even repatriating volume that's going to your competitors. So this is in itself a growth strategy, which there's not a lot of those on offer. So they really like that. Second is, being able to load balance volume. So one of the things you find at a large, metropolitan hospital, you will find the rate limiting asset to be the ORs. They're just, every OR is booked, you can't get enough time on the robot. When you go to the smaller community hospitals, the rate limiting resource is the surgeon. You don't have the variety of surgeons you would have at a big metropolitan hospital. So how could we load balance capacity of surgeries such that the capacity utilization of these very profitable ORs goes up, so that your economic value goes up? And then the third thing, we hear a lot that, oh my gosh, all these surgeons are really busy. But if you really analyze the time of a surgeon during an OR day, you find that more than half of the time of that surgeon during a typical OR day is waiting for rooms to turn. So if you could give them additional rooms at different locations to operate during the downtime, you could actually increase the productivity of those surgeons, which, as I talked about earlier, is such a scarce resource, is a huge value proposition. Health systems spend a great deal of money recruiting and retaining these very qualified surgeons. So if you can increase productivity, and then, maybe an added benefit is you can actually drive increased utilization of the capital intense robots if you're able to bring new surgeons onto those robots from a remote location. So imagine in a small community hospital, a general surgeon using the robot, but really only using it a low percentage of the time. If you could have a gynecologist, a urologist, a colorectal surgeon use that robot when the general surgeon's not, you get more utilization on that robot, which the cost per case goes down, and you actually also feed the economics of that community hospital, which is probably a very important resource in that community, that the surgery keeps the lights on.
So the I guess a summary statement on what Cynthia just described is, by enabling remote, and you started your question, Henry, with the expensive robot. I mean, what's more expensive than the robot are the specialists and subspecialists, as well as the ORs. And so we're enabling the better usage of all three of those resources, the robots, the specialists and the subspecialists, the ORs, and that in the models we've done should drive the cost of care down and improve the quality of care in the process and improve accessibility to care for patients.
I'm interrupting today's episode to bring you a word about one of our sponsors, Fundamental VR. If you go back to season 1, you'll find a great episode with Richard Vincent, CEO of Fundamental, on all the reasons why training in the virtual world can shorten the learning curve and reduce training burden and costs. Improve competency at scale with interactive digital twins of your surgical robot or medical device in a high-fidelity virtual environment. Drive commercial success with Fundamental VR's virtual reality solutions. So that's super interesting. So what are the risks when we go to telesurgery? So obviously telesurgery, we've had it since Project Limburg, which I'd like to ask about later and to get some info on that. But obviously telesurgery is not common practice today. In fact, I'm not sure there's any FDA cleared devices that actually have telesurgery just yet where they've got the actual clearance for it. So obviously that means there's risk factors. So what are the risks to telesurgery and where can it go wrong? And I guess how does your platform look to solve some of those risks?
Well, maybe I'll drop in on the operational and clinical risks. Obviously, we're bringing new technology in, so we need to train teams to use the new technology appropriately. So managing the risks of understanding how to adopt the technology is a training workflow management issue. So a lot of what we're addressing in the Sovato platform is training and coordination of care. One of the things we take very seriously is it is the contingencies. What if something goes wrong during the case? And this is no different than for open cases, laparoscopic cases, in the room robotic cases. There is always a plan for the things that can and will go wrong, whether it's the power goes out and the generator comes on, whether it's you need to convert a laparoscopic case to an open case because something didn't go as planned. We will have the same type of contingency plans that care teams will need to train on, know and understand. There's a little bit of role redefinition in telesurgery, so that will need to be part of the contingency. Our clinical teams are working with our clinical partners to develop and test and vet and validate all of those contingency plans for the things that can and will go wrong. But luckily, as an industry, this is familiar territory.
I think with regards to the technology risks, we've already talked about us using fiber as opposed to wireless technologies. I think that the core backbone of our network is going to be 5.9 reliability, which if you translate that to time, it means it can go down up to 6 minutes a year on a 24/7 basis. The on-ramps and off-ramps may be less than 5.9s, maybe 4, even 3.9s, which gets to a few hours of potential downtime over the course of a year. So we will have kind of automated backup switching, and so there will be redundancy in the whole thing. Then we are building our software platforms to have coordination, so that we're always connecting the right two pieces of technology, and there's checks, and that's actually done in combination with what Cynthia was talking about, the operational side. So we're basically making sure that the care team on the patient side and the surgeon go through checklists and things like that in order to make sure we're operating on the right patient, doing the right thing, timing things correctly, and things like that.
Cool. So you guys are agnostic across a number of surgical robotic platforms. It doesn't matter what therapy area it is, it doesn't matter what company. So how do you enable it for the surgical robotics companies? And I guess why would they decide to go on the Sovato platform, or if it's even a choice, whether the health system just decides it and they jump on? Talk to me about how that works with the robotics companies.
Well, so maybe I'll start. And first of all, let me start from the point of view of the customer. And if you remember my last company, InTouch Health, we did telemedicine applications like telestroke. We ended up in a few thousand hospitals around the country, so pretty well penetrated. And we've worked with thousands of hospital IT departments. I can tell you with certainty that the hospital IT departments aren't going to want to have a penetration through their firewall from company A to do this procedure, company B to do that procedure, company C to do this. Their firewall is going to end up looking like Swiss cheese. And so what we do believe from the customer's perspective, the hospitals and health systems, they're very on board with the concept of one well-curated, defined network, which they can have a lot of knowledge about, and Sovato will be that person, that organization, which we talking to them to make sure that they're comfortable with not only the ongoing monitoring, but also the maintenance and continued advancement of the network. And then we've, talking to nearly all of the different robotic companies out there, and I think categorically, it's not their expertise. First of all, if you design a surgical robot, it doesn't mean you've brought in expertise on networking, okay? And so combined with the argument of what the customers want, even the big players are talking to us from the perspective of, yeah, we want to use your network as opposed to try to develop our own.
Okay, so how do you stop your network from looking like Swiss cheese, like the hospitals might?
Well, so the Swiss cheese I was referring to is, you imagine a firewall, which is the firewall where they keep out all the bad stuff on the network. That was the Swiss cheese. We will make one hole, and one hole in that network will then support all of the different companies, different devices, as opposed to each one having their own hole. So it will look like solid cheese with one hole.
So I guess, as for a layman who's not technically savvy, I'm just trying to understand, so are they poking holes in your firewall and then you kind of filter it out so that they can, go in? It's going to be good for the listeners rather than the people watching the video. But is it like where you guys have your own firewall, you do a lot of the first stage sort of screening and then poke one hole when you know it's secure, or is that kind of how it's working?
So the firewall belongs to the hospital, not to Sovato. And so the firewall is what the hospital does to determine what traffic they let in and don't let in to their internal environment. And so we have to get them to agree to let our traffic in. And so that's the piece I'm talking about.
And so one of the things that if you're a robotics company, you are expert at building these amazing machines that also you have to build instrumentation and tools that go procedure by procedure. So there's a lot of skill and a lot of effort and capital at the robotics companies going into maintaining and developing the robot. Sovato, on the other hand, is developing, a team of the best network engineers who know how to manage cybersecurity, latency, bandwidth, all of the things that make the CIO at the hospital sleep well at night, because they know that our team is only focused on making sure that his or her hospital is safe using our access to their network so that their robots can work effectively every time and safely. So it's really, dividing expertise. So what we diagnosed when we thought about how do we bring telesurgery to the market was, there isn't someone focused on this network security expertise like we can be to enable this confidence between the robot and the health system players.
Okay, sure. So we're talking about robots right now. So you've just released a study this week with virtual incision. Can you tell me a little bit more about what that study was tracking and what that really means for you guys and virtual incision?
Sure. So we collaborated with some surgeons at the University of Illinois Chicago, and they set up a study before we started the demonstration. And the goal was to really understand, what does it mean to the surgeon, and how do they feel? What's their level of confidence collaborating with a local team, with a care team that's not in the room with them, and on technology that's new and unfamiliar. So they did a series of tests, and the bottom line, and a paper will be coming out under Dr. Francesco Bianco's name soon, that surgeons felt a high degree of confidence, and they were able to manage under very little stress in this environment. So we're very excited to have that data, because that's one of the questions. Will surgeons be able to do this? And we had 7 surgeons, undergo a battery of questions to understand this.
So then on the technical side, this was between Lincoln, Nebraska and Chicago. So it's about 500 miles. And so we were measuring the network, monitoring it the entire time through the 7 procedures. And and the delay was about 16 milliseconds round trip delay for 500 miles. And then it had about a millisecond or so of jitter. So in other words, the 16 milliseconds went up to 17 or down to 15 is the range. Now, just to put that into comparison, when you watch TV at night, that's refreshing the frame at about 33 milliseconds. So, when you watch TV, you don't see any stutter. It's pretty continuous looking. And the delay that we inserted into the whole path was about 15 to 17 milliseconds, so twice as fast, twice as little delay as a frame on your TV.
Yeah, so absolutely non-noticeable at all for a surgeon who's controlling the robot. Okay, awesome. So one thing that I want to go back to is kind of the regulator side. So you guys are looking at the policies, and so who actually will own the patient, do you think, in the surgical procedure? So you've said that they need to be state licensed. When you're doing it across state, they need to be licensed next to the patient. But who actually owns the patient, and what happens when something goes wrong when we're talking about telesurgery?
So our belief is that the primary surgeon will own the patient, and the primary surgeon will be the remote surgeon. So we'll be, creating the care plan and working with the local care teams as if they were, they will be credentialed in the same hospitals that the local care team is. So they'll have access to the same systems. So the thing that changes is not the ownership; it's really the location. There will likely be some additional systems and processes put in place to ensure, communication and collaboration that's not happening in the room, whether it be additional intraoperative AV, the ability for the primary surgeon to speak to the patient's family, pre and post surgery, et cetera.
The also that what Cynthia described is where we're heading. There are steps along the way, and many of the health systems and robotic companies we've been talking to have, for example, said, hey, we want to start with telementoring. So in that case, the primary surgeon is actually by the patient's bedside. The remote surgeon is potentially more skilled, or at least in the particular procedure, incapable, but the ownership of the patient has not the ownership of the patient has not transferred yet to the remote one. And then we evolve to what Cynthia just described, where the remote surgeon becomes the primary surgeon. So there's several, I gave you one step, but there's actually several possible steps along the way where that ownership kind of moves from one location to the other.
But I think you highlight an important point, is that this is one of the things that will need to be defined as telesurgery remote procedures roll out, is that for every instance, it's very well understood, which is not dissimilar to how ORs are run today. It's very clear in the OR, who's on point, and that will need to extend.
Okay, and so it's kind of spurred another thought, really, and being involved with telemedicine for such a long time, Yulun, you've probably thought about this in detail, but how do you maintain, obviously going for surgery is one of the most anxiety-inducing experiences of a patient's life, and this is all about the patient here. So how do you maintain that personal relationship and actually provide care to the patient when it's a remote surgery and things are done remotely?
You know, one of our first studies we did at InTouch Health is like probably 2005 or so. It was actually done with post-surgical rounding, and it was done at Johns Hopkins. And actually, what the study showed is that patients prefer seeing their own surgeon virtually than another attending in person. So the point being is that patients have no problem with virtual interactions, especially, in fact, they prefer it, and especially if it's the person that they know and trust. And so, as Cynthia mentioned earlier, doing pre-surgical visits, post-surgical follow-ups with the patient, with the family, that can all be done virtually. So the touch points, can be done very well virtually. I should give you another interesting analogy or example I learned in InTouch. Mental health is a big deal these days, right? And what we have learned, and this is documented, by different papers with the American Telemedicine Association, et cetera. In many cases, mental health patients prefer seeing their therapist or clinician virtually than in person. And one of the things that virtually often does is it gives the clinician comes across more attentive than they do when they're in person. So I think that, I think your question was to the potential loss of the human touch. If you do it right, you can actually even enhance it in many ways doing things virtually.
I think the follow-on question, Henry, is about patient acceptability. And I think we have seen with minimally invasive surgery and robotic surgery, the patient demand really being a major driver for the adoption of these new techniques. Of course, patients want smaller incisions and better recovery time and less pain. And of course, you want the best of the best. You want the person who does this procedure all day long. So we believe that patients, as they become educated about what the value prop of remote surgery is, will start to demand it. And we've seen many community hospitals who were early adopters of minimally invasive surgery and robotic surgeries really benefit from because of patient demand getting on the bandwagon. So I'm very confident that patients will find this to be of a benefit. But we do need to implement all of the support tools for the surgeons and the care teams to make it work so it's achievable safely.
Cool. And Yulun, you said about when you get it right. So how do you make sure that you get it right with the patient? You gave me a couple of interesting facts. But yeah, how do you make sure you get it right, and what does right really mean?
Well, getting it right, there's many dimensions to that. Okay, one is, for example, just how you use telemedicine. So we're all, we all have our head appropriately positioned in the frame here. Lots of times people, they'll use telemedicine and the remote person just sees the forehead of you just simple things like that in terms of using the tools effectively. A second piece of getting it right is where do you put it in the workflow, right? And when are the right times to engage with who through the whole process. So those are a couple of examples of getting it right, but that's the kind of thing I was implying.
Cool. And I suppose if you are looking at workflows and doing it from a digital side, then you can measure the data, and that will help with knowing how engaged the patient was, how you can optimize the workflow to make it better for the patient and the hospital system. So I can see it. So
my point, that's an important point, Henry, is that what's happening here is that when you have a virtual interaction, then the computer has access to all of the data of that interaction. And that's where, especially with the new kind of foundational AI models and the power of them, you can actually do a tremendous amount of data analytics to improve, all kinds of things, engagement, quality, et cetera, et cetera.
Awesome. So one final question on kind of the telesurgery and robotics side, but what do you think is the future of telesurgery and surgical robotics? So I'll let you both answer it, but Cynthia, let's start with you.
Well, I think we're going to see broad adoption across a variety of platforms, whether it be teleendoscopy, the remote traditional robotic soft tissue procedures, neurovascular procedures. There are many and fantastic robotics companies coming into the world to take on some of these very complex interventions, which will really just make more care available to patients. So, I think the future is really about access. I think the past has been a bit about, upskilling the surgeon, and now the future is about making sure that very skilled surgeon and those proceduralists can be available to the patients who need them.
And Yulun?
I think that, so one is, as Cynthia was describing, just improve access, which is critical, and it's a global challenge. And I think, remote surgery, telesurgery certainly helps address that. The other one is quality, right? Because, it's well known and well documented that practice makes perfect, and you have a lot of proceduralists, surgeons, interventionalists, etc., who just don't have the volume to be competent. And so you put those procedures in the hands of people who do have enough volume to be competent. You've improved quality of care. Quality of care should improve life for the patients as well as reduce cost. The other thing I might take this opportunity to add is I'm involved in a nonprofit called World Telehealth Initiative, and we use telemedicine to bring healthcare expertise to the underprivileged and the under-resourced areas of the world. And we think that what we're doing here at Sovato can be an enabler to actually just bring surgical care capabilities. Over half the world doesn't even have access to surgery, let alone quality surgery. And we think that over time we're going to be able to bring that capability to the rest of the world as well.
Okay, very interesting. So a final point that I just want to explore into is Project Lindbergh, because it's very famous within surgical robotics. So Yulun, it'd be a shame not to run through that. So tell me about how it all started and talk me through Lindbergh. What did you really do, and talk me through everything that's super interesting about it.
Well, I think it was 1999. Professor Jacques Maresco out of Strasbourg was already a good friend of computer motion, and he came to me and said, "Hey, I got to do this. I got to do this transatlantic operation. It's really the future of surgery, and I want to prove that it's doable." To be very honest, I was thinking, I was trying to run a company and try to make more money and sell the product. This was not going to do that, but if you've met Professor Maresco before, he's very charming and he's very persuasive, and he basically ended up persuading me. Yeah, okay, let's do this. So we put together a project, and it was so I guess it was probably a 2-year-long project where we had to go through. We had to modify a zoo system to be able to operate at distance. We obviously did dry labs and wet labs in addition to, in advance of the clinicals, and that was over that 2-year period of time. But also it was very, to get a connection between New York and Strasbourg, very expensive and very difficult. So it was Jacques Maresco who knew, he seems to know these very important people, and at the time it was the president of France was President Chirac. And he contacted his buddy, the President Chirac, who contacted the CEO of France Telecom to give us access to a dedicated ATM line. ATM line was the type of line that was prevalent at the time, and it was a line across the Atlantic Ocean. And then it's like Zeus was not cleared to be able to do anything like this. And so So this is one of those areas you kind of don't know if they have jurisdiction or not, as in the FDA. We went the safe route. We went all the way up to the commissioner of the FDA, where the FDA said, okay, you can do 3 cases of that. And so we actually ended up having to work through those channels, get the line laid, do the entire case, to set up to be able to do the entire case. And then on September 7th, we went ahead and did the successful surgery. Jacques Maresco was sitting not in an OR, but he was sitting in a data center in Manhattan. So it was just, if you look behind him, there was just racks and racks of computers like a data center. Obviously, it was in the operating room on the Strasbourg side. And we did it, and it was very successful. We had a couple of more patients lined up. We decided just to, call victory with the one. We did the procedure. That was good. And then we had the press conference set up for September 13th, so because the procedure is on the 7th, we had the press conference set up for September 13th, and then September 11th happened. So that was September 11th, 2001. So we never had the press conference because for obvious reasons. So anyway, that's a little more of the backstory. It was quite something.
I love all those stories from early days, and just I think that's so cool. It's like pioneering transatlantic surgery. It's absolutely awesome. So kind of to close this off then, so Cynthia, have you got any final comments or anything you want to leave the audience knowing about either your journey or Sovato, and then pass it over to Yulun?
Well, it's quite an ecosystem that will make this happen. The innovations of the robotic surgery makers, the innovations of pioneering surgeons and care teams and healthcare administrators who are willing to try this, payers, regulators. So part of what Sovato is aiming to do is to help bring this ecosystem together in a way that it can be very high functioning. So we're cheering on every constituent in this ecosystem so that they can be their very best, and we stand ready to do our part as sort of the convener of that ecosystem to bring it all together.
So, both Cynthia and I our entire career is healthcare. So we've dedicated our lives to healthcare, and the challenge has always been, how do you continually improve the quality of healthcare? How do you get it to everybody, or as many people as possible, and how do you reduce costs? All 3 of these things simultaneously. And then, in what area of healthcare do you do that? A huge part of healthcare is surgery and procedures. And it's really one of the most expensive parts of healthcare. And given all the different dynamics we've talked about in terms of the subspecialization of medicine, the access, the maldistributed populations we're trying to serve, this, we believe, should be able to hit all 3 of those points simultaneously. It should be able to provide better access to high quality care and do so at a lower cost. So that's why we're so excited to be working on this.
Amazing. Thanks for joining me today, guys. It's been a pleasure.